here, chapter 4. And let me get it big enough where everybody can see it. Hopefully. Oops, that wasn't what I meant. Went to the very end, I think. Oh, no. Okay, I'm going to get it to get rid of this. I think I do that by that. Okay, what page is, let me look and see what page chapter 4 starts on. That'll be the easiest way to get to it.
4 starts on 113.
113? Oh, I'm almost there, huh? Okay, there. Oh, it goes through so fast that I miss it if it's big like this. That's my only problem when I get it so big. Go back down for a minute, 100%. Okay, so what we've covered so far is we've learned the 3 structures of what we need in order to create any program. We need sequential, we need, sometimes we need if then else or decision, selection, sometimes that's called, and then we need repetition, which is loops, right? We need some form of loops. So those are the 3 structures that we can put in combination and solve any business or engineering type problem using those 3 types of logic. But then we have also looked a little bit at string arrays. We have looked at some of those in one of the chapters. We also talked about functions, because we wanted to be able to reuse code instead of copying and pasting code 2 or 3 times in a program. Also, you may create functions that you use in other programs down the road. So those are the things, the tools that we've learned so far in the first 3 chapters. Now in chapter 4, we're going to go a step further. That in my old logic class, or the previous logic classes, we haven't really talked much about data structures. We've talked always about logic structures and what we use to solve problems, but we also have to store our data in different structures. And usually we didn't get to this, but this is a very important part of programming, because in procedural oriented programming, which is what I did for 13 years before there was objects, you stored everything in files that were either on, they were on reel-to-reel tape, they were on disk packs, they were on different things, but you could only read a record and write a record. See, we don't even do things like that anymore because data is interactive. And so that's what we're going to look at, how data can be stored in files and arrays. And we talked a little bit about a string array and how to execute through it. But now we need to look at some, that's what only thing I was going to have trouble with. And here is my mouse going funky. Okay, so I'll try this. As your programs develop, you need to find ways to handle the data. And that's what this first part talks about, is data structures. And so let me do my view. Let's see what I have. Okay, first page. There. Single page. That's what it is. Okay. All right. So what the first thing that it talks about is in what they're calling Codeville, a Python program. We're going to write a Python program throughout this chapter that will process scores. So if you were given several scores of a student, how do we process those? Where do we store them? We're going to progress through the chapter learning different formats to store that data in. How many of you read the chapter? Anybody? Oh, a couple people. Okay, because you thought you were having a quiz, right? Okay, so here, this is what they're going to do is the scoreboard. Actually, this is not score. This is their surfing scores. And they're going to be posted up on this sign in the order of the winners. And so we want to find the highest score in the results file that's stored in a text file. So we're going to find a file in your files for this chapter that says results.txt. That's a text file that we're going to use, and we're going to read it. Now, remember in the beginning of the semester, we read a text file. We went and got a text file. It was HTML code, right? And we read it in and executed through the file to find certain characters. Well, this time we're going to take this file. You're going to need to write a program that reads through each of these lines and picks out the score and then works out the highest score in the surfathon. So what you notice on this clipboard, which if you've read the chapter, you know that this little thing right here is covering up part of the data that we're actually going to use later on, but which is the name of the person that got this score. So what we need to do is we need to access the file that has this information in it. Now, if I look over in, let me find it, this chapter 4, there's a file called results.txt. And this is what the file looks like. I'll make it a little bigger. This is what it actually looks like. It has the names of the people and right next to them their score. So what we need to be able to do is read one line at a time and find out which one is the highest score. Okay? So the way we do that, first, we're not going to look at the name. We're going to do it first with just looking at the numbers. So we need to iterate through the file with the open, for, and close pattern. So those three things that are underlined there are file handling functions. They're pre-built things that are already part of Python, and they're part of other languages too. Except for, I'm sorry, for is not a function. It's a loop. And what kind of loops have we been using up to this point? I know, dears, tell me. You know. What's the other kind of loop that we've been using so far? A while. So we've been using a while loop. So we started our loop with the word while. Well, we're going to use a loop called for in this particular instance of sorting through this program or going through this file. So we're going to have to open the file, and then we're going to have to loop through it, and we're going to have to close it. So that's what we see here in this statement. The first statement shows us result F. That's just a name that they've come up with, okay? They're saying this is like a variable name. So the opened file is assigned to a file handle. They're calling it a file handle called result F here. So it says open results.txt and set this equal to results.txt. The call to open creates a file handle, which is a shorthand that you'll use to refer to the file you're working with within your code. Because you'll need to read the file one line at a time, Python gives you the for loop for this purpose. Like while loops, the for loop runs repeatedly, running the loop code once for each of the items in something. Think of a for loop as your very own custom-made data shredder. And it shows you a picture, which I'd never thought of it like that, but I guess that is what it's doing. It actually, the for loop says, okay, the entire file is fed into the for loop shredder. Note, unlike a real shredder, the for loop shredder doesn't destroy your data. It just chops it into lines. So it's like you literally have the piece of paper, and the for loop is going to say, read line 1 and separate it from line 2, so the page becomes individual lines, okay? And that's what the for loop's going to do for us. So each time the body of the for loop runs, a variable is set to a string containing the current line of text in the file. This is referred to as iterating through the data in the file. And you may hear it called other things. Every textbook has different terms that they use, but that's really what you're doing. Iterating means executing, going one at a time through the data in the file. So each line variable is set to the next line from the file on each iteration. The for loop stops when you run out of lines to read. So that's what this Python code does. And that's what's so good about this book. Already there. So if you have any question, now the thing that's important also, remember in Python, and it's not important in other languages, that's the only thing I don't like about Python, is all the indenting and stuff and how it'll give you syntax errors if you're not indented correctly. Well, like JavaScript, it's very forgiving as far as indents. It's more for readability. So I guess that's why Python has you do it. It wants you to see every line of code that is part of the for loop. So here it says result f equals, so we're going to open this text file because that's what the program has to do first. Then for each line in result f. So every time it gets to a line, and this is part of the for loop keywords, for each line in result f, print each line. So it's just going to do something. You can put anything in this for loop that you want for it to do with that line of code. But they're just showing you, for instance, we could print each line as it goes through. And when there's no more lines, because it says for each line. So as long as there's a line, it's going to keep putting it into result f and printing it out. But the for loop checks at the bottom, and if there's, before it executes through and actually prints again, if there's no more lines, it's going to close the file. That's all that little bit of code does. Open the file, execute through each line. When there's no more lines, stop. So if you were putting that in a flow chart, that loop, you would have a decision box here that is testing result f if there's any more or not. If there's more lines, it's really testing it against each line to see if there's more of those lines. Okay, that's how we would, so it's really a loop that if it's still, it would keep printing, it would print, and then it goes back up and tests again and goes through the loop again. And as soon as it's no, then it just simply goes down. Well, I would actually make this go down further. This would go down, these would connect here, and it would end. And up here at the top is where you open the file. So it's kind of like an input box, right? Open. All right. So that's how you would see it pictorially in a flow chart, is that's what's happening in that little bit of code. Now, in our code magnets, now if there's anything that you guys need me to stop on or that you don't quite understand, please raise your hand. Okay, code magnets. You need to complete the code. Okay, we're going to go on down to the answers, but what they want you to do in this is the for loop creates a string from each line in the file. For the program to work, you will need to convert the string into a number. So that's what they want you to do in this code. For line in result f, if, it's asking you what it should be, and it gives you if highest score. I don't know, you've got to put those in the right places, but here is what should be. Let me see. For the program to work, you need to convert the string into a number. And I put a little note here that it's just like we had to when we had to do a conversion before. Remember, we had to convert some of those programs we did, we had to put int or float in front of them to convert. So here what we're saying is highest score, they're going to initialize highest score to 0. So what do I mean by initialize? What does that do? Highest score equal to 0. What does that do for us? Well, if we didn't put anything in it, what would happen when we got down here and did a comparison? Yeah, wouldn't have anything to compare it to, and it could have garbage in it, and so it could cause a data exception. It could cause problems. A lot of times it does not, but most of the time you're safer to initialize it with a value if you're going to do a comparison. So then we open our file. We set for line end result if float. So they're making sure that this line, they're getting the numeric value. So they're calling it float line is greater than the highest score. Highest score is equal to float line. If that's true, if the line of code is greater than 0 the first time, then it's going to move what that value is into highest score. And if you recall, when we looked at that file, the first score, oops, is that it? No, I got the wrong one. I guess I closed it. So the first one it's going to pull in is 8.65. So it's going to go into, oh, that's why that's happening. It's going to go into the, okay, so the first one is 8.65. So it's going to go into highest score. So when we start reading this problem through, if we did it before we run it with Python, we can tell if it's going to work. Because here we'll say if float line, well, because we say float line, it's going to skip right over that name. So it's going to take 8.65. Is it greater than 0? Because that's what highest score is at this time. Okay, if it's greater than 0, which it is, then float line will become highest score. So now the value that's in highest score is actually 8.65, right? So then we go back and we check again. Is there another line of code? Well, yeah, there is. Yes, there is. Maybe I should say. Okay, so let me see if this will let me open recent somewhere. There we go. All right, so the next one is 9.12. So it's going to go through it's going to execute through my program again, or through my loop, not my program. It's going to execute through my loop again. It's going to say if float line is greater than highest score. So is 9.12 greater than what it currently is? Yes. So it's going to put, now it will be 9.12. And it will keep going through the loop. And at the very end, the one that it kept in highest score is going to be the highest score, right? Okay, so to successfully run this program, you need to grab a copy of the results text data file. Okay, so we're going to run this program. I already have the one that was on this page. I think the first one was probably, yeah. Okay, I got it to where it would open without having to, extra problem, there it is. Okay, so here's the way it is typed in the book. Highest score equals 0, result F. So this program, now the one thing you have to be sure when you do this yourself is that this program is in the same folder with the results.txt unless you create the correct path and tell it where else it is. In other words, just put this in the same place like I have it here. I have results.txt in the same chapter 4 folder with my Python program, right? So it can find it. Okay, so now if I run this, it should take that in. Trace back. Oh, I was incorrect, right? When I said that it would bypass this. It does not. What does it do? It says, could not convert string to float because it's two different kinds of data there. And so it could not convert it. It gave me an error. Anybody not understand that? What it's saying is I can't convert Johnny to float. I can convert this to float because it already is. But I cannot convert Johnny to float. So I need to do something different. What's that? Line.split, correct. That's what we're going to see next is a pre-built, predefined function called line.split, because what I was telling you is this ID, official ID, was covering the names in that file. So we wrote it without taking that into consideration. So now what we're going to do is use a function called split. Each line in the for loop represents a single string containing two pieces of information. So I want to cut those two pieces of information apart, but I want to be sure that the name stays lined up with that score. So you already know how to extract one string from another. You did it for Starbuzz back in chapter 2, and you used the find method. Well, here we're going to search for the position of a space in each line and then extract the substring that follows. And then we're going to use the built-in function called split. So you remember that's code that we don't have to write. Any predefined function that we can find. And where can you go to find all those? If it didn't tell us in the book, is there a list of them somewhere? Where do you go, Shelby? Do you have a list of them somewhere? How did you know about the split? Just remember from when you used it?
I read the chapter.
Okay, you had the chapter. Good. All right. There's also, if you go to W3 Schools, it should give you under Python a list of them. So I know if you ever wanted to write a more, maybe you were writing a little Python, W3, and you wondered where, I believe this has Python. It should. Is Python in here? Maybe not. Let me do this then. Predefined Python functions. There, it's in the documentation, I guess. There they are, built-in functions for Python. There's a list of them. I should probably save that. I'll save it and put it in. But that's so if there's something you're doing, like see, here's our print. And if you click on it, it even shows you all of the parameters that you can use with it. Here's our float that we use. Int's going to be there somewhere. GH. There's int. We used input. Remember, we've used a lot of these pre-built functions. We're going to, in this chapter, use the reversed also. Okay, so let's go back. So Python strings have a built-in split function. Now, the split method cuts the string, and it shows you here explaining what it does. It explains to you what it does using jars and a rock band as an example. Because what we want to be sure of, like I said earlier, when we split it, that it still stays with the name and the score stay together, right? Because you don't want Brad to get Zach's score or something. So that's why it's going through this it's called a multiple assignment split. And so here we want to make sure that the left side of the assignment operator lists the variables to assign the values to. So here it says take, this was a rock band equals Al, Carl, Mike, and Brian. And it says to use the function that belongs to rock band called split and put those values into these variables. So it's going to take Al and put it in rhythm because it was listed first, Carl and put it in lead, Mike to put it in vocals, and Brian will go into bass. Okay, just simply because of the order these are in. So that's why that's important when you list the variables. So it looks like you can use multiple assignment and split to extract the scores from the results file. So here's our current version, and they want us to write the version with the split. So this is the version where they add, there's the current, this is where they add the split. And so I'm going to go ahead and open it up. For the sake of time, I didn't type it all in, I typed it in at home. So name and score, we're going to have two variables. We're going to have the person's name and their score, right? And we want to split the line into name and score, all right? And then we want to test score to see if it's the highest score. Okay, so we're going to take out our if that was up there, and we're going to, let me go here to the next one. Let me see if I can find where I opened it. I think that's 125, right? Page 125, I hope. 24. Oh, I named it 25 because that was the test run. Okay, this one's it. Okay, so this is the one where we took highest score still set to 0. We still have to open the file. We still have the same for loop, but we added this line of code. We're saying we have two variables, name and score. So when you split line, put the first value into name and put the second value into score, right? According to our results file, does that work? It had only two values in it, right? Had the name and the score. Now, if we had more values in our line, then we'd need more variables. Okay, where'd they go? There it is. All right, so we're going to take the line and split it, and so it'll be two separate variables. So we want to take the score and put it as a float. So we want to say if float score is greater than highest score, then put float score into highest score. So now it should read it, right? But we haven't done anything with the name in this particular problem, right? We're just trying to find the highest score. Everybody see what it's doing? We got it? Can you see it from there, Cole? Okay. All right. Run. Oh, it ran that time. No error. Yay. The highest score was 912. Let's see if that's right. Is that the highest score? I don't see another higher one, right? So it did work correctly. But if we look back, what happened with name? We don't know whose score that 9.12 belongs to, right? Don't know who it belongs to, other than the fact that we can look at the actual text file and see that. Or was somebody that didn't know what's in the text file, your program needs to tell who that 912 belongs to. So we need more than one, and what if we need more than one top score? I guess it's going to do that first. So if we need more than one top score, maybe we need to know who came in second and third, then normally you would have to use the top three, up three highest and third highest. So we would need extra variables. This, we've been writing pseudocode But this is the first introduction to pseudocode in this textbook, right? I don't think it talked about it before now. So what it's telling you is this code right here is not Python, but it's similar, and it's saying, okay, if I need to solve this problem, I need to set all of these three variables to 0. Then I need to iterate through each of the scores. So in other words, that's saying I need a loop right there, right? That's what iterate means. Means I need to put a loop there. Then I have, if the score is greater than highest score, then set the third highest to second highest, set the second highest to highest, and set the highest to score. That's a lot of work, right? We're going to figure out an easier way. Otherwise, if the score is greater than second highest, then set the third highest to second, set the second to score. Otherwise, so they had to have 3 ifs, right? 2 nested ifs to figure out all the way through each line of code whether it was the highest or not, or the second or the third. So that's the logic that was written to do that. Okay, so how could we make this simple? Think about what would make the program easier to write. Check the box that you think would have the greatest impact. Do you think it would matter if there were no names in the file, only numbers? Our actual logic on the numbers would still be the same, right? So that's not going to help us. What if the scores came before the names in the file? Would that help anything? What do y'all think? Would it help? No. So if you look below, you already know the answer. If the data were ordered highest to lowest, that would help. Yes, I see someone shaking their head. Broderick, right? Or Hunter. Your last name. I remembered your last name. Okay. So if we sorted the data, which is something that you have to do over and over in programming, is you have to know how to sort. Back in the time when I was taking programming in the late 70s, early 80s, we had to take a class to get a computer science degree called data structures. And we had to write all kinds of sorts, binary sorts, binary tree sorts. We had to do it all in basic programming language on a mainframe. It was pretty tough, but it's a lot easier nowadays. You can just say sort and it'll sort it. Okay. Hopefully we've come some distance since then in our technology. So we've always, though, my point was that we always have had to sort data, whether it was in a static file that was stored somewhere, or whether it was interactive, whether it's just a text file, then we still need to sort data. So the way we do that in Python, ordering data within a program is known as sorting. And so there's the unsorted data, and an ordered or sorted copy of the same data, we could actually read the first 3 and know that we have first, second, and third highest scores if it was sorted in descending order. All right, so how do you order or sort your data? What happens to the original data in the file? Does it remain unsorted, or is it sorted too? Can the data even be sorted on disk? And if so, does this make things easier, faster, or slower? Well, sorting sounds tricky. Is there a best way? So it's easier in memory, but here are 2 very important choices that you have when you're sorting data. You can keep the data in files on the disk, or you can keep the data in memory. Does anybody know hardware enough to know what the difference is? What happens to memory when you turn your computer off? It wipes it. So if it's stored on a disk, and you know, this was when there was not hard drives, you know, that's when I first started dealing with computers. We had only floppy disk drives. So when you pull the disk out, You lost your data. You lost when you unplugged it, you lost everything. You had to start over again if you didn't back it up on a floppy disk. That's the first experience that I had with an Apple when I took it back to the store, when the Apple IIc came out, and I took it home and it didn't have a hard drive, and I was a mainframe programmer and the data was always there. When I went to work, I had a terminal and I didn't have to worry about that. So PCs to me, or any kind of personal computer, was useless. I was like, I don't want one of these things. I unplug it and everything I've done's gone. And the original ones, has anybody ever seen an Atari where it was on a cassette? That was how they backed up, was on a actual cassette. Everybody know what I mean by cassette? You guys are all so young. Okay, so that was what used to happen, was that whatever if you couldn't get your answer and print it out while that memory was still active, you lost it because there was no way to store it. When I started working here in '92, my PC only had 2 floppy disks in my office. It did not have you know what I mean by floppy disks? You guys haven't seen those either, have you? They were really bad because if you left them in the heat or the cold, your data was gone. You know, and we'd still experience that somewhat with a USB drive, but not anything like what would happen then. Okay, so if you have a very large amount of data, then the obvious place to put it is on a disk. Computers can store far more data on disk than they can in memory. Disk storage is persistent. If you yank the power cord, the computer doesn't forget the information written on the disk. But there is one real problem with manipulating data on disk. It is very slow because it has to read it and put it into memory and then calculate on it and put it back. That's what, or see if it's, and sort it and put it back. So that's the difference in data sorted on a disk. But you know, when you're buying a personal computer, when I teach intro to computers, students always ask me, okay, it has, you know, 32 gig of memory, but it has a terabyte of hard disk space. Well, you have to know the difference in those terms, but you can tell right off that there's a lot less space in memory than there is on that hard disk, right? So that's what you have to consider, is if you're sorting a customer file in a bank, that's going to be huge. You can't get it into memory, right? So you have to sort it on a disk. But with this little program we're doing, data is much quicker to access and change if it's stored in the computer's memory, but it's not persistent. Data in memory disappears when your program exits or when the computer is switched off, unless you remember to save it to a file, in which case it becomes persistent. Okay, so if we keep the data in memory, if you want to sort a lot of data, you will need to shuffle data around quite a lot. This is much faster in memory than on disk. Of course, before you sort the data, you need to read it into memory, perhaps into a large number of individual variables. So here, that's what it's doing. It's trying to put all of the scores into separate variables. You have lots of lines of data, so you'll need lots of variables, right? Well, this file isn't all that large, but most files are going to be a lot larger than that. So it would be really difficult to do that. You can't use a separate variable for each line of data, or it would take an enormous amount of variables. In this case, though, but how many variables do you need? Imagine the file just had 3 scores in it. You could write a program that read each of the lines from the file and stored them in variables called first score, second score, and third score. That would be relatively easy. But what if there were 4 scores in the file, or 5? Even worse, what if there were 10,000 scores? You'd soon run out of variable names and possibly memory in your computer, not to mention the wear and tear on your fingers. Okay, so sometimes you need to deal with a whole bundle of data all at once. So to do that, most languages give you what's called an array. How many of you had an array in math, like in algebra? you probably know what an array was then. Well, now we've talked about it because we used an array in strings. Well, now we need an array that lets you manage a whole train of data. Okay, so for that you need a type of variable called an array. It's the type of data structure it is called a collection variable. And each variable is really not a separate variable. Once you name the array, it has array elements. If you want to store a number in one element and a string in another, you can do that. So here comes the data train. Here's how you would define it. My array equals 7, 24, fish, hat stand. You notice if I'm storing it as a numeric that I want to do a calculation on, I don't put it in quotes, right? Because that would automatically make it into a string. Like this is a string, even though it's numbers. How do I know? In quotations. So that may be a number that I want to display as a score or an address or something, but I don't want to do any calculation or comparison with it. Enough. Even though an array contains a whole bunch of data items, the array itself is a single variable. So how are we going to use arrays? Python gives you arrays with a list. In Python, most programmers think of an array when they are actually using a Python list. For our purposes, think of Python lists and arrays as essentially the same thing. So you create an array in Python like this. My words equals, and you notice they're square brackets, dudes and. Give the array a name, assign a list of values to it. And there's something over here that explains more about that. You can read it yourself. So here, print my word sub 0. Now you remember in the strings when we did an array, the very first element, we used to think that 0 was not a number. That meant nothing. But 0 really is a number. From our decimal values are 0 through 9, which is the 10, which are the 10 numeric values that we define an array. So if we said print my word sub 0, it would print dudes. If we said print my word sub 1, it would print and. You can read individual pieces of data from inside the array using an index. And here's how you can extend an array if you want to add something to the end of it. You know what the word append means, add. So that's what this does. If you say my words dot append Betty's, then it's going to put Betty's on the end of that array in position 2. So here's our program. And this time we're going to rewrite it to read those scores in an array. So first of all, we have to define the array. And that's how we define the array. Go here, and this one is file 19. I think this one's it. Yeah. Okay, so it's saying here there's nothing in this array, but I'm saying I'm going to define scores, and instead of it being just a single variable, I'm going to make it an array single variable. And the way Python knows that is because I put empty brackets there. Then I open the file. I say for line end result, name score equals line split. So I'm still splitting scores dot append. So what is this line of code going to do? What will that line of code do? Anybody know? What if I have an array over here and it's called scores, and I tell it that it's an array, so I'm going to have positions in this array. I can put them down or cross however I want. This is position 0, 1, 2, 3, 4, 5, and so on. Okay, so it says scores dot append is float score. So what was the first score in my, if it's sorted, actually that's what this is going to do. Did I already sort it in the last one? I must have. Let me see. Oh, I can tell. Was that the one? No, that one didn't sort it. Okay, so what I'm going to do actually here is just read it. I'm not doing my if statement yet. I'm just, it's saying it is. Okay, let's see what happens. I'm going to run it because what it should be doing is appending. So it's adding to position 0, the first score. Let's see if I run. Oops. Oh, it didn't work, right? Didn't put highest score first and then the second highest and the third highest. All it did was print the first 3 scores out, right? Because I told it right here to only print these. So I could go down here and I could add oops, where'd that go? Come on. Oh, it's not letting me edit it for some reason. There it is. Oh, I thought. Let's see. There it is. But it did something weird. What'd I do? I don't know. It's messing me up. Let me open it again. That's that editor. That's why you use text edit or something, right, Jairus? Or whatever. Because that editor, you got to know how that editor works, and I'm not. Oh, it saved it that way. Now I won't be able to run it again. Okay, I'm going to open up the next one because we're about to run 140. I don't know why I put me on there. Okay, so on this one, it's going to sort because what did we find in Python? It had something, it has sorted. So it's using a sort function. So it says for line in result f, name score equals line dot split. So it's going to create the array called scores. So now all of my scores are in that array. So however many were in that result file are now in my array. And then I'm going to close the file, and then I'm going to use a function called sort. And the sort, the way it works, it tells you in the book, the way it works is it actually does it opposite. It does from the lowest to the highest score. So then I'm going to use the function called reverse, and it will read each one of those scores and reverse them. Okay, and so then the top scores will be 1, 2, and 3. There they are. So it did it according to, okay, let's go down to where that was because I want to give y'all a few minutes here at the end. So here's where it sorted them, and here are some of the functions that I was saying that are methods. They call them methods in here. They're either functions or methods. And so they have you draw a line to each of them. Those are the ones that you can use. Sort the scores from highest to lowest. And the very last part actually puts the names with it. Let me see which page. I did that one too. Where's that at? There you need the surfers' names. And I thought they told you how to do that. Oh, no, we do that in chapter 5. That's what it was. Okay, so at the end of chapter 4, you've learned to split a line, but you've learned about an array, and that's what chapter 4 is about. So when you get finished, you should have that should print it out in this order, okay? All right, so we've got a few minutes. If you already if you want to work on project 2 together, you can do that. If you want to work on it on your own, then you're free to go. It's totally up to you. But on Thursday, we're going to cover project 2 so that I can understand before the test, okay? All right, any questions? Everybody okay? And when we may do some extra problems on array before we go into chapter 5, and wait for chapter 5 till after spring break, okay? All right. If you want to work on it with somebody, or maybe you just want to do a hangout with somebody later on, that's fine too. Has anybody tried to start project 2? Anybody worked on it? No? Oh, she doesn't have a key. So Sarah has it. All right, so let me kill this and you all can, let me go ahead and kill the